review of transformations. This is part 2 of 3. I know that we did transformations before the break, and then we did area and circumference and composite figures, and now we're doing review and then taking a test on Friday. I know one of my sections took the transformation test already. You're going to take another one. It will be graded. It is timed. Okay, so I'm going to, because there was a gap in this section, I'm going to actually go over some key points that you need to know for your test. So you're going to need to know which transformations preserve congruence. And remember that our transformations are reflection, rotation, translation, and dilation. My apologies. I'm going to pause while I put him away. So of these 4, you need to know which one, when I do it, preserves congruence. And there may be more than one of them. So go back in your notes or think about which ones preserve congruence and which ones just preserve similarity. You will also need to be able to read an algebraic rule. So I can give you an algebraic rule and you can be able to tell me what transformation that is. You also will need to determine coordinates after transformation, and I'll demonstrate a couple of those in the review. You're going to have to decide which transformation occurred. So if I say, if I'm moving something, which transformation occurred, and you're also going to have to do dimensional change of perimeter, area, and volume. And there is a vocabulary piece. Now, the test is 50 minutes, and you should basically have a piece of paper and a calculator in front of you and something to write with. You should not have notes, and you should not have anything. You could have the star chart in front of you also. But you should not have notes. You should not have your vocabulary out. You should be taking it and doing that. That's the ethical part of taking the test on virtually. Okay, so right here it says use this trapezoid for the following. These are all do's. They're not just multiple choice. So in the figure, if the figure is translated 3 units to the left, where would coordinates G be? So I go here and I go 1, 2, 3, and that's G. And so to signify that it's the new point, I would do G prime. So, and then I look at it, and it would be -3, 3 is where that point is located. Okay. I didn't change the y, so the y is going to stay the same. But what I did is going to the left is x minus 3. And so the algebraic rule is xy transforms into x minus 3, y. If the translation, this occurs, what are the coordinates of j? So I'm going to take j coordinates and put -1 and 1 here. And if I do -1 minus 4, I get -5. If I do 1 minus 2, I get -1. If the figure is rotated counterclockwise about the origin, what's h? So if I do h, and I have 2, 3, and I do counterclockwise, if I start here, I go 90 degrees counterclockwise, which is to here, so that one becomes the negative. This slides down and becomes a 2. This slides down, and this 3, make sure that doesn't look like anything. That 3 slides down the arrow and becomes a -3. So the coordinates is -3, 2. Write the rotation algebraically. So when I have this, I have xy, x slides down, y slides down but changes the sign, so xy transforms into negative yx. So make sure you go over all those translation rules. If the figure is reflected over the x-axis, what are the coordinates of I? So I is 3, 1. Over the x means x is almighty powerful, and y has to change its attitude. Write an algebraic expression to represent the reflection, and I said x is all powerful, so he doesn't change, but y has to change his attitude. So that is a demonstration of a couple of problems. The next video I'll go over the next page of the review.